Hello, everyone. My name is Nilis Deniz, and I'm the Stunner Product Manager at Unchained Labs. I will be your moderator, and thank you for joining us today. We will have a Q&A session at the end of the presentation. To ask questions, all you have to do is click on Q&A in the Zoom navigation bar at the top or bottom of your screen and type your question. We will get to as many of them as we can. And now I'd like to introduce Evangelia, but we call her Leah Androulis, our field application scientist for our analytics portfolio. Today, Leah will take us through how Stunner evaluates some common labeling reactions for protein recovery, degree of labeling, and aggregation, all in one look. And now I'll hand it over to Leah.
Thank you, Nellis, for the introduction, and thank you everyone for attending today. This webinar will demonstrate how you can use the Stunner to monitor different labeling parameters all at once. Now, something obviously is missing here. The picture is not complete. You may not recognize this picture, maybe you do. Is this the Mona Lisa? We're not 100% sure because there's a main piece of the picture missing. How can we be sure if it's actually the Mona Lisa? When labeling antibodies, we can come across a similar scenario. Issues such as low antibody recovery, low degree of labeling, and even aggregation can occur. So just like that Mona Lisa picture, the information you get on labeling your antibody by just looking at one parameter is an incomplete picture. Now, label antibodies are widely used in biological research. We have many different types of labels, for instance, fluorescence-based labels, such as Fitzy. These are commonly used for signal amplification. We also have small molecule labels, such as Biotin, and the two of them together are used for immunoassays, bioimaging, also to detect proteins in Western blots, and also flow cytometry. These two, Fitzy and Biotin labels, are very popular, and these will be the focus of this webinar. Now, there are two different factors that we need to optimize when labeling antibodies. First, of course, is the degree of labeling. This is going to tell you how much dye is going to attach to your antibody. A common presumption made, though, is when you're labeling your antibody, that antibody maintains its integrity. That's not always the case. So in addition to measuring the degree of labeling, we also have to monitor the structural integrity of our antibodies. So in other words, looking for aggregation and also monitoring the percent recovery of the antibody. There's a fine balance here between those parameters. If you have a low degree of labeling, of course, you're going to have a weak signal and perhaps no detection. If you have too high of a degree of labeling, this leads to a higher risk of aggregation and even loss of antibody function. So we need to find a way to find out these two parameters at the same time. This is where the Stunner can help. The Stunner is the first and only instrument that has both full spectrum UV vis and dynamic light scattering, or DLS, all in one instrument. The combination of these two detection methods allows us to get a better, more in-depth analysis of our biological samples. The Stunner provides information on concentration, sizing, polydispersity, in other words, all the different sizes in your sample, B22 and KD, which are colloidal stability parameters, and homebrew. Homebrew is an option where you can design a unique application based on your own sample needs. So now with this combination of UV-Vis and DLS, we can now get more information on our labeled antibodies. We can see concentration before and after the label. We can get degree of labeling, percent recovery, and also monitor if any aggregation occurs all at the same time. This is done with very little sample volume. The Stunner requires only 2 microliters of sample, and there really is no need for sample prep or any dilution. The Stunner plates are SBS compliant, and as we see here, this a 96 well plate layout. You have very fast runtime as well. So to run 96 samples for just concentration will take about 12 minutes. If you add in the DLS, you can get both done in about an hour. The unique design of the microfluidics allows for no cross-contamination or no evaporation of your samples. And as you can see here circled, we have two fixed path lengths where your sample is red. It's a 0.1 millimeter and a 0.7 millimeter path length. And because we have these two, you get a higher dynamic range when it comes to optical density. The range is 0.03 all the way up to 275 optical density. And this correlates to 0.02 mg per mil to 200 mg per mil for protein concentrations. All right, now on to the experiments. So first we tested Fitzy. Fluorescein derivatives and their conjugates, of course, are some of the most popular labels out there just because they have high absorptivity, also very good fluorescence quantum yield, and good water solubility. Fluorescein isothiocyanate, or Fitzy, is used as a fluorophore. It has a maximum absorption of 490 to 495 nanometers and a maximum emission of 520 to 530 nanometers. Now, the Fitzy labeling occurs with this isothiocyanate group attaching to the amine groups of your antibody. The Fitzy labeling process also requires an incubation period and then a wash period. And the wash period is pretty much to get rid of any excess unlabeled dye and unlabeled antibodies. And from here, we can get the amount of label associated with the antibody. In other words, the degree of labeling. Now, for our experiments, we wanted to optimize the degree of labeling. So we had our molar ratio and the incubation time as our variables. We used the stunner to measure concentration via absorbance and the sizing via DLS. Now, the antibody that we tested was giving us some challenges because it doesn't have many amine groups. So it was giving us a very low degree of labeling. Our goal here now is to get a degree of labeling of 1 to 2. So in other words, 1 to 2 Fitzy molecules per antibody. In our first experiment, we incubated the antibody with 20 times molar excess of the Fitzy and incubated it for 1 hour. Here we're showing the full UV spectrum of the A280 measurements of the antibody by itself on the left in blue and the antibody plus the Fitzy on the right in green. And the Fitzy peak you can see is apparent here at that 495 nanometers. Once we added the Fitzy, we noticed a decrease in concentration. This gave us a percent recovery of our antibody of 90% and a degree of labeling of 0.71. Now, this is a little lower than what we wanted. In order to increase this degree of labeling, we tried increasing the incubation time. So now what we have is incubation time of 2 hours. We kept that same molar ratio of 20 to 1 Fitzy to antibody. In this case, we also noticed a little decrease in the concentration, again, giving us a percent recovery similar to before. Now we're getting 89%. But our degree of labeling actually doubled. We got 1.4. This looks promising. This is actually in the range of that 1 to 2 degree of labeling that we're aiming for. The next experiment that we tried was increasing the amount of Fitzy. So we increased the ratio of Fitzy to antibody to 40 to 1. Now, note, we did this by decreasing the concentration of the antibody to achieve that 40 to 1 ratio. Now we notice by increasing the molar ratio, we actually see a greater increase in the degree of labeling. However, we see a percent recovery of 77%. This is a lot lower than what we saw before. So increasing the amount of Fitzy may not be as ideal as increasing the incubation time for this particular antibody. So in summary, from the UV-Vis experiments with the Fitzy, we noticed that increasing the incubation time actually increases the degree of labeling without significantly changing that percent recovery of our antibody. This is shown in blue here. Now, when we increase the molar ratio of the Fitzy to antibody, this is where we also see an increase in degree of labeling. However, there's a trade-off where we have a lower percent recovery, and this is shown in yellow. So being able to measure characteristics of our sample with the stunner all at once, we can make a better informed decision on which of these conditions to choose with the Fitzy. But now we're actually going to find that missing piece, because remember, we have DLS as well. With both UV-Vis and DLS, the stunner can provide more information now to help us find this missing information. So DLS can provide us a few pieces of information about our sample. We're looking at the colloidal stability before and after adding that label. DLS provides information about intensity distribution. As we see here, this is the antibody without any Fitzy. The intensity distribution is going to tell you what different sizes are in your sample. So the antibody alone was registering a size of 11.01, and we see one peak. Once we start adding the dye, we have a 20:1 Fitzy at 1 hour incubation. We're starting to see a larger species form. In other words, aggregation is starting once the dye is added. The second piece of information that the DLS can give you is the mass distribution. Mass distribution is going to tell you how much of each size is in your sample. Now we see here on the top for the antibody, the mass distribution is actually registering 100%. So that means that there's 100% of that sample, that size in the sample. When we look at the 20:1 Fitzy at 1 hour, we also see the mass distribution is showing one peak. However, if we look at the actual numbers, we see 0.02% is that second peak. So it's a very, very low mass percentage. This is showing you that the intensity of the DLS is proportional to the diameter to the 6th power. In other words, DLS is very sensitive. So it's going to be able to detect very little amounts of large items. That's why we see the peak here showing up in the intensity distribution for the 20:1 Fitzy 1 hour sample, but we don't see that peak in the mass distribution. So this is something where you have a piece of a little bit of aggregation occurring that perhaps could be filtered out of your sample. Now, what happens when we increase the incubation time and also increase the molar ratio? How is that going to affect the colloidal stability? The top distribution curves here, the intensity distribution on the left in green and the mass distribution on the right in blue. This is for the 20:1 Fitzy incubated at 2 hours. So we're doubling the amount of incubation time. We also see here some aggregation forming. But again, if you look at the mass distribution and you look at the actual peak to mass percent numbers, we're getting 0.5%. Again, a very low value. Similarly, when we have the 40:1 ratio of Fitzy to antibody incubated at 1 hour, we're actually seeing a peak to mass percent of 0.15. So ultimately, by adding Fitzy, we are seeing aggregation in all different scenarios. However, if you look at the mass percentage of this aggregation, they're all on the low end, all something that could easily be fixed, perhaps through filtration. So ultimately, looking at all the Fitzy experiments and combining the UV-Vis and the DLS information, we can say that aggregation in this case is not that big of an issue. However, when we look at the addition of the increase in Fitzy to antibody, and we saw that percent recovery go down all the way to 77%, that's a little bit more concerning. So in our case, we decided to choose that the longer incubation time for our case gave us the best degree of labeling for this antibody without sacrificing too much of the antibody integrity. Now on to the Biotin experiments. The combination of Biotin labeled antibodies with Avidin or strep Avidin items, this is usually done when the target is at a very low expression and you need to enhance that signal. So multiple Biotin molecules can be conjugated to these Avidins or strep Avidins. And in our case, we use HABA, which is a 4-hydroxyazobenzene 2-carboxylic acid. And here we have 4 HABAs attaching to the Avidin. This has an absorbance value at 500 nanometers. And we're showing the full spectrum of the HABA-Avidin complex in green on the lower left. The Biotin that has the antibody labeled to it now comes in and replaces that HABA. And once this is done, the absorbance at 500 nanometers then decreases. This spectra is shown here in yellow on the bottom left. Now, the homebrew application in the Stunner can now provide us a unique application designed specifically for this one experiment. We can create an application in homebrew and have it saved for future uses. So in short, what we did here, we used Homebrew to define the hava-avidin as our blank, and we subtracted the hava-avidin biotin spectra from that, and thus we were able to get the antibody concentration. Now we performed the same exact experiments we did with the Fitzy with the Biotin. We used the incubation time and the molar ratio as our variables. Here we use the UV-Vis to measure the antibody concentration. We got a value of 2.10. When we added Biotin at a 20-to-1 ratio, incubated for 30 minutes, we noticed again a decrease in concentration, giving us a percent recovery of 90%. Now we're seeing a degree of labeling of 3.06. For the Biotin experiments, our target range was 3 to 5 for degree of labeling. This 3.06 is right in our range. Great. Now, what happens when we increase the incubation time? We have 20-to-1 Biotin now incubated for 1 hour. Here, we actually see less of a decrease in the concentration, a better percent recovery, 97%, and a degree of labeling of 2.39. Still close enough to that 3 that we're looking for. And then finally, we increased the amount of Biotin to 40-to-1 ratio and incubated that for 30 minutes. Here again, we see a percent recovery of around 91%, and a degree of labeling actually went up to 4.14. So this is just a graphical overview of the numbers we just saw. Now, yes, the amount of Biotin does matter. If we were just to focus on the degree of labeling, we would say the amount of Biotin actually, the larger amount of Biotin actually gives us a higher degree of labeling. But remember, that's not the whole picture. We have our DLS again. Now the DLS is going to give us information on the colloidal stability before and after adding the Biotin. So in this particular case, we have again, the intensity distribution and the mass distribution of the antibody by itself shown on top. We were getting a value of 10.65 for the size of our antibody. And as you notice here, we only have one peak in the sample, and the peak 1 mass percent is registering at 100%. So that sample is all at that one size. When we add 20-to-1 Biotin at 30 minutes incubation, we're noticing very similar distributions, very similar to the antibody by itself, 100% peak 1 mass, which is great. No aggregates are showing up in this sample. Now, what happens when we have the longer incubation and also the higher molar ratio of Biotin? This distribution curve here is showing the longer incubation time at 1 hour. Again, we're noticing peak 1 mass percent is registering 100%. No aggregates are forming. This looks promising. Now, when we increase the amount of Biotin to 40-to-1 with the incubation time of 30 minutes, now we start to see some aggregation forming. But if you look closely at the numbers, the peak 1 mass percent is still registering at 100. The actual number is 99.9999647. That means that the peak 2 mass percent is insignificant. This goes back to what we mentioned earlier, that the DLS is very sensitive. The intensity is proportional to the diameter to the 6th power. That's why that one aggregate is showing up. So again, we get that information on how much aggregation is occurring and also in which conditions. So for the Biotin experiments, if you didn't want to have any issues with aggregation at all, you wanted to get something that had the highest percent recovery and also a degree of labeling that's close enough to the range what we're looking for, then that 20-to-1 Biotin ratio incubated at the 1 hour would be the best bet in this case. So overall, as we see, using the stunner, we get a whole bunch of information on our samples all in one run. You have simultaneous, you have the investigation of the percent recovery, the degree of labeling, and aggregation all done simultaneously. And again, all with very small sample volume. Only 2 microliters of sample was needed for the Fitzy experiments and for the Biotin experiments. Now, using all this information that you get from the stunner, you can determine the best label to antibody ratio. And in our case, we chose the 20-to-1 Fitzy at 2-hour incubation and the 20-to-1 Biotin at 1 hour incubation. Both these conditions gave us the best degree of labeling without sacrificing too much of that antibody performance and functionality. So now with the Stunner's unique combination of UV-Vis and DLS, we can now find the necessary pieces to complete the picture of our sample behavior after labeling. And now we see that this is the Mona Lisa. And with that, I would like to thank you for your time and attention, and I'm happy to answer any questions.
Thank you, Mona Lisa, for taking us through how Stunner can help you achieve your optimal antibody conjugation. We already have some great questions that have been submitted. Anyone else, you can still ask a question by entering it in the Q&A section of your Zoom navigation bar. Are you ready for the first one, Leah?
Yeah.
Okay. Is there an application for labeled proteins that we can use, or do we need to make our own, or how does that work?
Yeah, so there is a particular application called labeled proteins that you can use. All you would need to do is enter in the specific dye absorbance that you, whichever dye you're using. You also need to put in the molar extinction coefficient and then the E1% of the protein. Once you do that, the system will give you back the degree of labeling and also your antibody concentration, your protein concentration. So yeah, so there is a pre-designed application already there.
Great. Second question, can you comment on the wavelengths range that you captured during a run with Stunner? Do people have to specify their range, or?
Yeah, sure. So the Stunner has the full spectrum UV-Vis. So you can measure from 230 nanometers all the way up to 750 nanometers. There are a whole bunch of different applications on the Stunner. Some have preset wavelengths. For instance, your A280, you would have 280. You also have the UV-Vis measurement where you can input 3 specific wavelengths of your choosing depending on your experiment. Of course, you also have the homebrew application where you can put any wavelength you want to have monitored. So there's a lot of flexibility with this instrument. There's also the capability of once you do an analysis, you could always go back and reanalyze your samples, changing up whatever wavelengths that you'd like to focus on.
Great, thank you for that. Third question, can you test samples with labels other than Fitzy and Biotin in the same way?
Yes, exactly. So you would be using that labeled protein application and simply enter in all the information you have on the dye that you're using. And another great feature, you can actually save that information for future use. So you have that, whatever dye you're using, you have that now on the drop-down list in the software.
Sounds perfect. What is the size range that DLS can measure?
The DLS can measure anything from 0.3 nanometers all the way up to 1,000 nanometers. So it's your standard DLS size range.
Great. Can the Stunner measure labeled nucleic acids as well?
Yes, actually. So the great thing about the Stunner is that there are pretty much 2 libraries of applications. You have your protein-based applications and then the nucleic acid-based applications. Multiple applications within each one. And for the nucleic acids, yes, so you have labeled double-stranded DNA, also single-stranded DNA, and RNA, if you're interested. So yes, there are applications as well suited for the nucleic acids.
Perfect. How many samples can you run at a time? Can you run different types of samples in one run?
Yeah, that's a great question. So if you remember the layout of the plate, it's a 96-well plate format. You don't have to run all 96 samples at a time. You can run one at a time. You can run multiple plates at a time, actually. So it's a high throughput instrument. As long as you tell the software which samples or which wells you'd like it to read, that's all you really need to do. When it comes to running different types of samples, this is another unique feature that we have in our software where you can actually group samples. So let's say you're trying to compare 2-3 antibodies in one run. they have all different buffers. You can actually run those in the same run. All you would have to do is specify in the software which buffer goes with which sample group, and you can run them all at the same time.
Perfect. We have a couple of more, if you're still up for it. Can you run colorimetric assays in the stunner?
Yeah, so again, that's another application that is underneath the protein menu. And yeah, you could do the BCA, the Lowry assay, and the Bradford assay. Those are options as well inside the stunner.
Okay, and I think we have one final question. Someone's asking if he couldn't do this with just regular UV, what makes it special to do this with homebrew or with stunner overall?
So technically, yes, you can do all these measurements with just UV vis. Of course, you won't. The DLS would not be extra. The thing with homebrew, it just makes it so much easier to have a pre-made application ready at your fingertips. You know, you don't have to worry about doing the calculations all the time. It's just one step closer to getting your results. Yeah, no, I mean, you do, if you want to do a lot more calculations and a lot longer experiments, you can do it with UV vis. Stunner, I guess, is there to make your lives easier.
Yep, that's exactly that. Sounds like we had all our questions. Thank you for answering all of them. Thank you for that great presentation. I also want to thank all of you who joined us live today. If you would like to have a deeper conversation with our team, please do get in touch with us at info@unchainedlabs.com or visit our website at www.unchainedlabs.com. We would love to connect with you. Thank you again for attending our virtual seminar, and I hope you have a great rest of your day.